Okay. So in today's session, we'll be seeing solutions for GATE Aerospace Engineering jet propulsion questions. And the first question, as it says, a turbojet engine with a bypass ratio of 5, the mass flow rate through core of engine is provided. Core of engine, as in it is the hot mass flow rate that they have provided. Velocity of the hot gases is 600 meters per second. Velocity of the mass flow rate is 120 meters per second. And the bypass ratio is given as pi, that can be defined as m dot cold by m dot hot. We have to find out the static specific thrust. So first, let us begin by understanding statics. First, let us write the thrust equation. So thrust equation can be divided into two parts, one for the hot and the other for the cold. So for the hot, we will write thrust in this fashion. Here they have given that it is static specific thrust. So static as in the velocity of the incoming mass flow rate is 0, or the vehicle is at stationary. So Vi is 0. So this gives us the specific thrust equation as, and they have written in terms of core mass flow rate. So this can be replaced as thrust by m dot hot. That can be written as so here we can write in terms of bypass ratio, just substituting the values that they have provided, we can obtain the final static specific thrust, that is 1200 Newton second per kg. Moving forward, there is a centrifugal compressor which is having a diameter of 10 centimeters, that is 0.1 meters, and shaft speed n is given 460 rotations per second. We need to find out the tangential velocity at the tip. Tangential velocity is nothing but the blade speed u, which is defined as pi dn. Pi can be written as 3.14 times diameter 0.1 times 460. This gives an approximate answer of 153 meters per second. Moving forward, they have given an axial flow compressor which has a 50% degree of reaction. So DOR is 50%.
Yeah.
Blade
Shruti, we
speed
can
U
ask
is,
if these given data are correct. We can ask those who are watching this session.
yes please. If you find that there is some variation in the data, then you may please comment in the live chat.
And they can ask any doubt also if they have.
Yeah, please stop us any moment. We are willing to answer any queries you have. I'll be continuing. Please feel free to just drop a message in live chat in case of any doubt or in case of any correction in the questions. So the degree of reaction is given as 50%, blade speed is given as 250 meters per second, axial velocity CA is given as 200 meters per second. The pressure ratio across the compressor, which can be denoted as pi C, is given as 1.3. Initial temperature T01 is given as 300 Kelvin, and these are common data for air. So we have to find out rotor blade angle at exit, that is beta 2. So what we'll do is we'll try to write two equations and try to solve it simultaneously. So one equation being from the Euler work done equation, which is same as the enthalpy rise that is occurring in the compressor. Euler work done equation in terms of blade angles can be written like this, which is equivalent to the enthalpy rise that is occurring across the compressor. So I'll try to put the blade angles as a subject and the other things on the right hand side. So here CP, U, CA are provided in the question. T01 is also provided. I'll take it out common. Whereas this T02 by T01, this ratio can be written in terms of isentropic relation. So T02 by T01 can be written in terms of the pressure ratio, that is pi C raised to gamma minus 1 by gamma. Hence, you will be the entire RHS will be known to us. So this becomes our first equation. The second equation, however, comes from the degree of reaction information. So they have given 50%, which can be denoted in terms of blade angles again. So this becomes our equation 2. If we try to simplify, what we'll do is we'll try to subtract 1 from 2, equation 2. So then we'll be able to get, I'll again write equation 1 and 2 so that it is so this becomes 1 and this becomes 2. We will subtract 1 from 2. So we will get on LHS, we'll get 2 times of tan beta 2. In RHS, we will get, in the final stage, we can just replace all the values. So here beta 2 can be tan inverse of U by CA is 1.25 if you put the values. This entire term turns out to be 0.4694 and this 2 taken in the denominator. So hence in degrees you will get it as 21.32 degrees. Please feel free to ask any questions at any moment. So for this question, they have given an ideal ramjet. So in case of ideal ramjet, the Mach number of the inlet is same as Mach number at the exit. This is the characteristic of ideal ramjet. They have given exit temperature as 700 Kelvin and ambient temperature or the inlet temperature as 260 Kelvin. The inlet is given as 60 kilopascal. And gamma and R are no different for the exit as well as inlet. So we will consider it same. The mass flow rate m dot I that they have given is 50 kgs per second, and they have told that fuel flow is negligible. So m dot exit is nothing but m dot I plus m dot F. But here this mass flow rate is of fuel is negligible. So we consider m dot T same as m dot I. We need to find out the thrust produced. So in order to find out thrust, we will write its equation is m dot E VE minus m dot I VI. So here we will write it as m dot E as same as m dot I, so we'll take it out common. And we will try to find out what is the velocity at the exit. That becomes as the speed of sound times the Mach number at the exit, and the velocity at the inlet becomes the speed of sound times the Mach number at the inlet. So this will give you as hence if you multiply the mass flow rate and try to replace all the variables, you will get thrust as 31 kilonewton. So here they have given a stoichiometric combustion equation for methane and ammonia. They have asked to find out the variable x. So what we'll do is we'll try to do a stoichiometric balance of all the carbon, hydrogen, nitrogen and oxygen on LHS as well as RHS. So what we will do is we'll try to write in the form of table what they have given. For first carbon at LHS you find 3 moles, and at RHS it is A, whereas for nitrogen it is 2 moles, and in RHS it is 2C. For hydrogen it is 4 times 3 plus 3 times 2, that becomes 18, whereas on the RHS it is 2 times B. And finally for oxygen, here they have given 2 times X plus so it becomes 2 times X here in the LHS, and at the RHS it becomes 2A plus B. So from above table you can clearly say A is 3, C is 1, B turns out to be 9, and hence 2 times X is equals to 2 times of 3 plus 9. It becomes 15 by 2 or 7.5 moles. Here they have given, it's a air is flowing at a temperature of 300 Kelvin. It is compressed isentropically from 1 bar to 10 bar in compressor. So pi C is 10, T01 is 300 Kelvin. There is 80% of compressor air is supplied to the combustor. So if m dot A is the total mass flow rate that the compressor is seeing, only 0.8 of m dot A is going into the combustor, which is mixing with the fuel. So the heat that is added is, or the calorific value of the fuel is 0.8 megajoule per kg. Cp they have asked to consider same 105 kilogram per Kelvin, and gamma is 1.4. We need to find out the temperature leaving the combustor, which is T03. You see through TS diagram. This is the compressor, this is the combustion chamber. So the temperature leaving the combustor is the station 3, so T03. So what we'll do is we'll try to do an energy balance in the combustor. So the heat energy or the chemical energy that the fuel is having is getting converted into the enthalpy rise in the combustion chamber. So m dot F CV is equals to m dot A. So 0.8 m dot A plus m dot F Cp T03 minus 0.8 m dot A Cp T02. So here you will take out m dot F as common. So this becomes calorific value 0.8 times fuel. F denotes we'll take out mass flow rate of the air as common. So we'll get F denotes mass flow rate of the fuel by air. So this becomes 0.8 plus F and CpT03 minus 0.8 CpT02. So what we'll do is we'll consider F to be much smaller than 1. So what we'll do is we'll try to replace that and write it as 0.8 times Cp T03 minus T02. So here what we'll do, we can find out what is T02 using the isentropic relation T01 pi c times gamma minus 1 by gamma. Pi c is 10. So we'll try to find T02, which comes around 579.209 Kelvin. And CV is provided, Cp is provided. So the only unknown can be T03, which can be evaluated. This turns out to be 1454.83 Kelvin. So yes, this is the end of propulsion questions, jet propulsion questions from the GATE Aerospace Engineering paper 2025.
So thank you, Shruti. And I think these are the memory-based questions, and there There may be some more questions and there may be deviation from these questions, guys. So these questions really based on what data we got from our students. Thank you, guys. So next session will be flight mechanics. Or before that, guys, we can do one questions which is asked from space dynamics. So let's see that question quickly. So thank you, Shruti, for your time.
Thank you, sir.
If you guys have any doubt, can ask quickly. Shruti is there before we start next session, guys. Yeah, guys, any question? Quickly, any question for jet propulsion? If you guys remember any theoretical questions or any conceptual question asked in exam, and if you have doubt, be free to ask. I think Shruti, they don't have any question. So we'll start the session.
Okay, sir.
Thank you. Yeah. So Praveen, you are there.
Yes,
You
sir. Yeah.
can, yeah. So I will make you presenter. You can start. I'll take one question which is from space dynamics towards end. Yeah. Yes.
Okay. So, good evening, friends. So, today we'll be discussing some questions which are asked in the GATE 2025. So, the feedback was this paper was, not was like easy as compared to last year. Okay, but nonetheless, I hope everyone has done good in this exam. Okay. So today we'll focus on some questions that are asked in the flight mechanics section. So let's get started.
I think Praveen, you have to change track. Did you upload your presentation?
Okay, 1 minute. I have to do that. I think the button is not there in the screen. Just 1 minute.
Yeah, I'll make you presenter.
Can I make presenter? Yeah. 1 minute. Okay.
Yeah, yeah, please. I think Praveen, there is some issue. Did you convert? Okay, I think he got disconnected. Uh,
It shows please try reloading the page. Okay, I think so. There's some issue. Can you ask Ruthi to present first? I'll see what's the issue on my side.
no, Shruti has done.
Okay.
Okay. Did you convert to PDF?
Yeah, PDF is
Therefore,
done. Yeah,
you retry. Meanwhile,
yeah.
I'll take up.
I'll
Okay.
reload. Yeah. Okay.
Yeah.
Mm,
Can you please load again?
yes, sir. 1 minute.
Yeah. Or what you do, please share with me in WhatsApp. I'll do that.
Okay, fine. Yeah. I'll send you as a PPT, a PDF itself. Yeah.
Yeah.
I sent you, sir. Yeah.
Yeah. Yes, Praveen. Please continue.
Okay. So sorry for the hiccup, folks. Okay, so let's get started with our flight mechanics questions. Okay, that was asked in Gate 2025. Let's get started. Okay, so this was a question that was asked. So we don't have that much data, but we'll just try to figure out what the answer is. Okay, so which is laterally destabilizing. So you have four options: swept back wing with positive dihedral, fuselage with a high wing, and fuselage with a low wing. Okay. So if you recall the basics, if I consider this as the fuselage and the low wing and a high wing, okay. So we saw that fuselage without a dihedral was destabilizing. Okay, fuselage without dihedral wings, that was found to be a destabilizing effect. That was found to provide a destabilizing effect. And for a high wing, we found out that it was providing a stabilizing contribution. Okay. And if we go by that analogy, then option D is the correct answer, because swept back wing is obviously stabilizing. Okay, because our CL beta stays negative. Okay, so that's why. And for this case also, no, this is also perfectly valid. and these two are valid, and this is also high wing statement is stabilizing. So only thing is this is actually destabilizing answer. Okay. So the correct answer is D. Okay. Hope that makes sense to everyone, right? So moving on to the next question. An airplane is flying at 90 meters per second. The Venturi meter with area ratio 1.3:1 is mounted. What is the pressure difference at the same location of area ratio given in the Venturi meter? Right. So you have a Venturi tube. So it says it is flying at 90 meters per second. So which means the test section conditions are given for us as 90 meters per second. Okay. So it says station 1 and station 2, and they are given the area ratio, which is A1 by A2. That is 1.3 by 1, which is 1.3. Okay. So if we apply the Bernoulli principle, which is P1 plus rho V1 square by 2, that is equal to P2 plus rho V2 square by 2, we can easily get the P1 minus P2, which I can write it as and if the density value is given, okay, so assume the density value is given. Okay, if you substitute in the values, so let's say density I take it as 1.225, and if I take the V2 common out, okay, V2 square divided by 2, and I have 1 minus V1 by V2 whole square. Okay, and substituting the values in here, I mean I'm assuming that the density is given, so this time go ahead with the values. Okay, 90 square by 2, 1 minus V1 by V2. So if we use the continuity equation, so I have A1 V1 is equal to A2 V2. So from here I can write A1 by A2 equal to V2 by V1. So that means V1 by V2 is nothing but A2 by A1 whole square. And if I substitute this, d square by 2, 1 minus A2 by A1 is 1 by 1.3 square. Okay. And if I evaluate this, so I'll be getting an answer of minus 1.3 square. I'll get P1 minus P2 as 2025.599 pascals. Okay. I mean, depending on this density value. Okay. Once we get the actual question paper released by the gate committee, then we will discuss in detail about the steps and the values to be plugged in. Okay. Right. So this is the procedure basically to solve this question. Okay. So moving on to the next question. A rectangular wing with chord of 1.2 meter and aspect ratio of 5 is tested with velocity 30 meters per second. Density is given as 1.225 kg per meter cube and viscosity is 1.8 10 power minus 3 pascal second. So when you have pascal second, that automatically implies that is the dynamic viscosity. For the same Reynolds number and the same wind tunnel, for testing wing with aspect ratio 6, what is the velocity? Right. So we have the Reynolds equality principle. The Reynolds number stays intact, so that means I can write rho 1 v1 l1 by u1, that is equal to rho 2 v2 l2 by mu2. But since the conditions are same, okay, rho 1 rho 2 will be same, mu1 mu2 also be same. Only parameters that vary in here are v1 l1 and v2 l2. So v1 is given as 30 meter per second and v2 is asked. Okay, so let me write down that. And V2 is to be determined. Okay, and L1, how do you get L1? So L1 is this chord over here. Okay, so it's a rectangular rectangular wing, by the way. So the aspect ratio can be obtained as the product of the span times the chord. Okay, so I can get the span because he mentions the same wind tunnel, so which means the span will remain fixed. Only the chord can be varied. Okay, so I can write 5 is equal to B times 1.2. So from here I can get the B as 4.166 meter. Let's keep that aside. So I can let me substitute it in here. I'll have 30 times L1, which is 1.2. That is equal to V2 times L2. So we have to get L2. How do we get this? An information is given, an aspect ratio of 6. Okay. So how do you get this? Is very simple again. Having said that the B is fixed, only parameter that you can vary is in C in a wind tunnel. So that means I can write still that aspect ratio of 6, okay, which is nothing but again B times C. So B was 4.166 times C. So from here I can get C as 1.44. Now if I substitute back in that, and this C is my obviously L2, okay. So if I substitute the data into this, so I'll have 30 into 1.2, that is equal to V2 times 1.44. So from here I can get the V2 as 30 into 1.2 divided by 1.44, and that turns out to be 25 meters per second. Okay. Hope that is clear to everyone. Okay. So moving on to the next question. Right. Okay. Let takeoff distance for an airplane is given as S and final velocity is V. When the takeoff distance is 0.5 S, the velocity is alpha V. What is the value of alpha? Okay. So that again is a very simple question. Okay. So he says consider this as a runway. When the distance is S, the final velocity is V. Okay. And when the distance is 0.5 S, let me just it as S by 2. He says the velocity is alpha. Okay. So sort of like a boundary value problem. Okay. So we know that this comes under our linearized aircraft performance, wherein which we have to use the Newton's law of motion. Very simple equation: P square is equal to U square plus 2AS. Okay, right? So since not much of information is given about the U, so we'll assume U to be 0, which is the initial velocity of the aircraft, or we'll assume that the aircraft starts from rest. Okay, so that's what this implies. Okay, so the aircraft starts from rest. So we have two conditions, 1 and 2. Okay, so let's evaluate for 1. I have V square is equal to 0 plus 2AS. Let's keep this aside. Okay, this is nothing but 2AS by the way. Now for condition 2, I have alpha V. So alpha V whole square, this is equal to 0 plus 2A times S by 2. Okay, so I'll have alpha square V square is equal to AS. Okay. So from this I can write AS as V square by 2. Okay, I'll have in here V square by 2. V square gets cancelled off. I'll have alpha square is equal to 1 by 2. So that simply means alpha is equal to plus minus 1 by root 2. Okay. So you can take the positive value obviously. So alpha is 1 by root. Hope that is clear. Okay. So moving on to the next question. An aircraft was in a steady level flight. Rate of climb is 10 meters per second. CD naught is 0.02. CL is 0.8. Aspect ratio is 8. E is 0.9. Velocity of flight is 80 meters per second. What is the thrust to weight ratio? Again, this is a very baby level question. Okay, we have solved like this in our test series and classes. Okay, so what is the rate of climb formula? The rate of climb is given as V sine theta, where V is nothing but the velocity of the aircraft times the sine theta is nothing but T minus D by W. Okay. So the rate of climb is given, velocity is given. What is asked is the T by W. Okay, so let's substitute that, plug in the data. So 10, that is equal to 80 times. Let me write T minus D by W as T by W minus D by W. Simple manipulation. So from here I can get T by W as 10 by 80 plus D by W. Okay, but recall in a steady level flight we have drag is equal to W by L by D, right? So we'll have to plug in that as well in here. So which means I'll have thrust to weight ratio will be equal to 1 by 8, which is 0.125, plus 1 divided by L by D. So we only know the CL, we have to get the CD. So how will you get the CDs? So CD is equal to, your CD naught plus KCL square. Okay. Substitute that over there. So my K is, from aerodynamics, comes in as CL is 0.8 square by 5 into 0.8 into aspect ratio, which is 8. Okay. And if I do this, I'll get CD as 0.02 plus 0.8 square by 5885 into 0. I'll get CD as 0.0624. So plug in all the data. 0.125 plus 1 divided by 0.8 divided by 0.0624, and the answer turns out to be 0.203. Okay, hope that makes sense to everyone, right? Again, so this is again a very simple question. All you have to do is just a bit of manipulation and bingo, you arrive at the answer. Okay, fine. So I hope there are no doubts, in solving these questions. Okay, so please await, further information from the GATE committee, and once they release the official question paper, we'll solve all the questions that are asked from the flight mechanics section. Okay, and you'll have an idea of how difficult the question was and sort of things. Okay, fine. So I hope there are no doubts. Okay, if anyone of you has any doubts, please feel free to post it in the chat box. Okay, we are here to help you. Any questions? Any doubts? Okay. Dinesh sir, I think there are no doubts. So can we wind up?
Yeah, we can wind up.
Okay. Okay, guys. So see you and have a good day.
So thank you, Praveen.
Thank you, sir.
Thank you, guys. Yeah, we'll start the last section of today's. So there is one question from Space Dynamics, guys, and that is for 2 marks, and that question seems to be easy only. So what is given? They have given the center of planet. It may be Earth. Under the influence of that, uh, one object is moving under the influence of that. Okay, and they have given certain positions of that object, or you can say the radius vector. Okay, so they have given at point F what is the radius vector RF, and they have given the radius vector at G. So in this question you can see this P is perigee, O is the center of attraction. Okay, center of attraction. Now guys, here in given problem, they have given theta f equal to 0 degree. So that means ideally this point F and P should coincide. And P is like OP is what? Local horizon, and P is what? Perigee. They have given theta G, which is 60 degree. So guys, what is asked in this question? Eccentricity E is asked for this orbit. Okay, the orbit in which object is moving. So guys, we know at any position what is your radius vector for elliptical orbit. Okay, for elliptical orbit, what is your radius vector is given by r equal to h square by mu upon 1 plus e cos theta. Okay, now guys, here what is h? H is angular momentum, right, per unit mass. And what is mu? Mu is gm. Okay, Now guys, we do not require these data because what is given, your RF. So what is RF? It is h square upon h square by mu upon 1 plus E cos 0. And what is RF value? I believe it is given as 8,000 kilometer. What is RG? RG is h square by mu upon 1 plus E cos 60. Okay, cos 60, and this is given as 10,000 kilometer. Now guys, just take the ratio of RF by RG. So it will be what? It will be 8,000 divided by 10,000, and this is equal to what? This is basically equal to 1 plus E cos 60. Cos 60 is what? 1 by 2. Then 1 plus E. What is cos 0? 1. So from here what we get? We get 0.8 into 1 plus E is equal to plus 0.5 E. Okay. So now from here guys, what we see, 1 minus 0.8 is equal to what? 0.8 minus 0.5 E. So 0.2 is equal to 0.3 E, and from here E will be 2 by 3, which is 0.6, 0.667. So eccentricity for this orbit is 0.667. So that simple was this question. Okay, so guys, there may be confusion because they have mentioned these two as separate point, but when angle is 0 degree means your F should coincide with point P. So any doubt guys in this question? Anybody have attempted this question? So eccentricity is given by what? 0.667. So Praveen, this is correct, right?
Yes, sir. Yeah.
Yeah.
I got a fan.
I think
If
that
the
was
data is
the
correct, then our approach is correct.
yeah. If like anything else given, then we have to say otherwise. This is the only way to solve because we know trajectory equation for elliptical orbit, and they have mentioned two different positions where theta is given, and from there we can take the ratio of radius vectors and we can find eccentricity.
Yes, yeah.
So thank you guys for watching this session. And if you guys have any further doubt or concern, you guys can reach on this number or can write mail to us or visit our website for different courses provided by IGC. Currently, admission is open for our first batch for 2026, and which is going to start from Feb 23rd for GATE 2026. Okay, and admission is already open, and tomorrow we are planning for a demo class for SAM, and then see you guys tomorrow who are interested for GATE 2026. Good learning from IGC, and basically IGC is known for team support, and we are not like few faculties institute. We have multiple team member to support each and every one at all crucial times of preparation. You guys can also follow us on our YouTube channels for more updates, or can join our Telegram channel for regular updates, daily quizzes, free lectures and all. Thank you guys. So in last two sessions, out of 65 questions, we have solved almost 45 questions, guys, which are memory based questions. And you guys can see most of the questions fall in the category of easy or maximum moderate. Okay, so guys, the result for this year also will be on the similar line of the results should be on the similar line of last year, or maybe close to 2019 2020 result. Yeah. I think, Praveen, there is one doubt. Can you look? Somebody is asking aspect ratio equal to B into C or B by C. Should not be dimensional less.
1 minute, 1 minute.
Hmm?
1 minute, yeah, yeah. I think I messed up that formula. 1 minute. Yeah. So actual aspect ratio is B by C only. Okay. So I think I did this thing, simple mistake there. Okay. But I mean the procedure is same. Okay. So in the wind tunnel, your the span is fixed. Okay. So your B is fixed. Only your C varies. Okay. So based on that, you have to go ahead and calculate. Okay. So that's the key thing. Okay. But the procedure remains the same. Okay. So once you get the C1 for the first case, L1 for the first case, you can get the L2 for the second case as well. Okay.
Okay, I'll just make you presenter. You can go and correct. Please
Sure.
go to that. You have to move to that presentation.
Mm-hmm. 1 minute. Mechanics. Thanks for pointing it out, guys.
Yeah, this
Right.
next
So
slide. Yeah.
let's do again a bit of workaround in here. Okay. So aspect ratios. I'll redo this problem. Very simple. So the aspect ratio is nothing but B by C. Okay. So for the first case, I believe it is given as 5. Okay. So I have 5 is equal to B by C, which is 1.2. So that means the B is 6 meters. Okay. So let's keep this. Now for the second case, the aspect ratio is given as 6. Okay. So that is again B by C2. So B is fixed, okay, in a wind tunnel. So only C2 varies. So that means C2 can be obtained as 6 by 6, which is 1 meter, right? And this is my L2 obviously. So that means I can write V1 L1 is equal to V2 L2, and substituting the data, I have in here 30 times L1 is 1.2. Okay. That is equal to V2 times 1. So that means I have V2 is equal to 30 times 1.2. I'll have a velocity of 36 meters per second. Hope that is clear. Okay. Thanks for the correction. So this is the correct
Yeah, I think answer was earlier also 36, right? So only that. Yeah, in between that.
Corrected solution.
Yeah. So fine then. Thank you, Praveen, and thank you, Shivam, for correcting this. Yeah, thank you.
Thank you.
Okay, guys. Then thank you, guys. See you in post-grade guidance sessions, or when response it comes out to be, we'll solve each and every question of each, and we'll be providing key as early as usual. Okay, IGC will be first among all to provide key along with the detailed solution. Thank you.